Welcome back to your own channel Brainic Education Physics, and today we are just going to explain this question that is asked by one of our student named Daksh. So this question is just belongs to the resistance and resistivity. In this question it is asked that if the resistance is decreased by 20%, then what percent of diameter of wire should be increased. As we know, the relation between the resistance and the diameter is inversely proportional to each other. So by decreasing the resistance, we all know the diameter will be increased. Alright, so here first we have to find the relation between the resistance and diameter. So here we assume there is a wire of diameter d, and the length of the wire is L. The main concept in this question that we will use, that we just keeping our length is constant. All right, we just vary our diameter, so all time our length is remain constant. So now just move to the topic and just go for the relation that we know is R, that is equivalent to rho is the resistivity, L upon A, where rho is the resistivity of wire, resistivity of conductor, and we all know that it is a constant. All right, and we just keeping L is also constant, so only area is the only quantity that is just varying. So we all know that the area is here pi r square, where r is the radius, and if we are using this in term of diameter, we all know that diameter is equal to the 2 times of the radius. So the value of the radius in term of diameter is d by 2. So when we put this and find the area, then A will become pi d square upon 4. Put this value in this equation. So we have that R is equal to rho into 4 into L upon pi d square. All right, so here we can see that rho is the constant, rho 4 and L and also pi, these all values are constant, so we can say that R is inversely proportional to 1 upon d square. All right, so here if resistance in first case is R and d is the diameter of the wire, and when we are just decreasing the resistance by 20% of its initial value, so we can see the final final resistance is R dash. So R dash is inversely proportional to 1 upon d dash square, if we just assume that d dash is our final diameter of the wire. So we can relate these two terms, and we can write that R upon R dash is equal to d dash square upon d square. All right, so we have the value of R, that is we are just assuming that R is our initial resistance, so all we have to just find is R dash. So we know that in the question it is already given that final value of resistance is the 20% lesser than the initial value of the resistance. So for R dash we can just say that R dash is equal to R minus 20% of R. So here we can write R minus R into 20 upon 100. So it will become 10r minus 2r upon 10. So it is 8r upon 10. So it will become r dash is equal to 4r upon 5. So put this value of r dash here. Alright, so we get that r upon what is the value of r dash is 4, r upon 5 is equal to d dash square upon d square. So we can say that r is cancelling r, that 5, it will become 5d square upon 4 is equal to d dash square. So here we know that we find that d dash is equal to root 5d upon 2. Alright, so this is the value of final diameter. So in this question it is not asking for the value of the diameter, but it is just asking for the percentage increment in the diameter. So for that we just using the basic formula, the percentage change in diameter is just calculated by the simple formula that initial, no, you can use the final minus initial, upon initial into 100, and the term is used diameter, final diameter minus initial diameter upon initial diameter into 100. So here we put the value, the final diameter is root 5 d by 2 minus initial diameter is just d upon d into 100. So here we can use the 5 root 5d minus d upon 2 d into 100. Alright, so here the d is cancel to each other, and then we only have under root 5 minus 1 upon 2 into 100. So if we just calculate the value of root 5, it is where is the calculator here? If we just find the value of root 5, that is 2.236, so we can write it 2.24. So just put this value here, so it will become 2.24 minus 1 upon 2 into 100. So this is 1.24 upon 2 into 100. So you can write it 0.62 into 100, so we can write 62%. All right. So guys, there is a problem here. We just did it wrong from here. Here we just put minus 1, and if we just calculate it here, so it will become root 5d minus 2d, because we just taking the LCM here. So we just did it wrong here from here, so we just rewrite it from here. So this will become root 5d minus 2d upon 2 upon d into 100. So now it is right. So it will become root 5d minus 2d upon 2d into 100. So here we just take out the d outside and it will cancel the d from the denominator. So it will become root 5 minus 2 upon 2 into 100. So we just calculate the value of root 5, that is 2 point look, we just check it again, that is 2.24 upon 2 into 100. So by dividing this term by 2, we will get 1.12. all right. Sorry, just we did it again wrong. We just forget this 2, all right, into 100. So this will become 0.24 upon 2 into 100, and we can write it 0.12 into 100, and there, so d percentage change in diameter is equal to 12%. all right, so this is the answer. All right guys, I hope you guys will understand it, and if you like this video, please hit the like button and share this video and subscribe the channel. all right, thank you guys.